In the previous video, we had studied about what a balanced chemical equation is and what in all are its components. So basically, it follows the law of conservation of mass. If you've not checked it out, do check it out. In this video, we are going to be talking about stoichiometry. Now, stoichiometry has been derived from two words, that is stoichion, which means element, and and metron, which means measure. So our balanced chemical equation will give us a symbolic representation of a chemical reaction. In stoichiometry deals with the calculation of various masses of reactants and products in a chemical reaction. So in stoichiometry we will be studying about how masses, volumes, moles and all of these are related to each other. For this we need a chemical reaction. Let's consider a chemical reaction, that is CH4 plus 2O2 gives rise to CO2 plus 2H2O. So this is a balanced chemical equation because the number of elements or the number of atoms on the reactants is equal to that of the products. Now this is a balanced chemical equation, right? Now qualitatively we get to know what are the various substances which take part in a chemical reaction. Here we know it's methane, okay, oxygen, giving rise to carbon dioxide and water. Now this is the qualitative information that we get from a chemical reaction. Now quantitatively speaking, there are various or rather a lot of information which a chemical reaction provides. Also one more thing, the ones in brackets which show are the ones which show what the state of the particular substance is at. So G means gas, L means liquid, AQ means aqueous, which basically means that particular substance is dissolved in water, and S is solid. First, it gives us the information of the relative number of reactant and product species taking part in a chemical reaction, which means it's giving us the information about the molecules. So, molecules. So, this means that one molecule of methane is reacting with two molecules of oxygen to give rise to one molecule of carbon dioxide and two molecules of water. Quantitatively, it is giving us the number of molecules. Just that all you need to do is you need to write whatever is written over here. So on the left side, if there's nothing, it means there's one. So one molecule of methane reacts with two molecules of oxygen to give rise to one molecule of carbon dioxide and two molecules of water. The next, it gives us the relative number of moles of reactants and products. So it gives us the relative number of moles, which means that 1 mole of methane reacts with 2 moles of oxygen to give rise to 1 mole of carbon dioxide and 2 moles of water. And next, it gives us the relative masses of reactants and products. We are talking about masses. So, which means mass of methane 12 plus 4 is 16 grams. Mass of oxygen is 16 twos are 32. Again into 2 because there are 2. So 2 into 32 grams, which is equal to 64 grams. Next, carbon dioxide is 44 grams. And again 2 into 18 grams, which will give us 36 grams. So here, if you notice, if you add this and if you add the respective values of these, it will be equal. which means it's in accordance with law of conservation of mass, and so this is a balanced chemical equation. So here 16 grams of methane is reacting with 64 grams of oxygen to give us 44 grams of carbon dioxide and 36 gram of water. Now notice all of these are gases, which means they also give us the relative volumes of gaseous reactants and products. Is applicable for gaseous ones, and the chemical reaction gives us the relative volumes, which means 22 point. So 1 mole, basically 1 mole of a particular gas at standard temperature and pressure is 22.4 liters volume. Okay, this is a standard thing which is considered. So volumes at STP. So since there's only 1 mole, 22.4 liters. Now here you have 2 moles, which means 2 into 22.4 liters, which is equal to 44.8 liters. And then here also you have only 1 mole, so 22.4 liters, and 2 into 22.4, that is 44.8 liters, which means 22.4 liters of methane reacts with 44.8 liters of oxygen to give rise to 22.4 liters of carbon dioxide and 44.8 liters of water. So, a balanced chemical equation qualitatively gives us the information about the individual reactants and products which are formed, and quantitatively it gives us the information about molecules, moles, the mass and volume. Remember, you need to learn this. Okay, so when you talk about molecule, we only write down molecule, and mole is this value which is present on the left of that particular substance. Mass, you have to calculate the individual masses, and if it does have a number in front, you have to multiply the mass with this number. Okay, so basically oxygen's atomic, the mass would have been 32 into 16 into 2, that's 32, that's the mass of O2, and then we multiplying it by 2 again, because multiplying it into 2 because of the 2 present in front of the oxygen O2. Okay, same goes for water as well. The reason we multiplied it by 2 is because when we balance the chemical equation, we realize that number of atoms are not just 2 and 1, we multiplied. So the volumes, on the other hand, as we know, at standard temperature and pressure, based on mole concept, the volume is supposed to be equal to 22.4 liters. 1 mole of any gas equals to 22.4 liters at STP. So number of moles of methane are 1, so it has 22.4 liters. Moles of oxygen are 2, it has 44.8 liters. Carbon dioxide is 1, again 22.4, and water is 2, 44.8. With that, we finish the basic idea behind stoichiometry. Now, in stoichiometry, you have certain things called as stoichiometric calculations. In these calculations, you will have mole-mole relationship, mass and mole relationship, volume relationships. Okay, so all of this basic thing will give you the idea as to how to calculate the various numericals that will come forward.